The real gains from computer vision and artificial intelligence basically comes from the outdoor use cases, such as the smart city use cases or your surveillance use cases or digital signage use cases. But unlike indoor environments where you can basically control the variables surrounding your use case, be it lighting, temperature, etc., you cannot do the same for outdoor environments. Hi, I'm Alphonse. In today's episode of my podcast, Unraveling Computer Vision and Edge AI for the Real World, we will be talking about the different lighting problems you might face while building an outdoor based computer vision application and what are the steps you can take to solve it. In a nutshell, there are four major problems which you will encounter when you're building a computer vision application for outdoor environments. The first is lighting. As you're well aware, the sun is not a constant or consistent source of lighting. The sun, depending on the time of the day, will provide you both bright light and low light periods, and you should be able to manage that while building your computer vision application. The next is temperature. Computer vision components are affected by the variations in temperature it is subjected to. For example, if you are placing your computer vision hardware component in a place where you have huge temperature variations, such as let's say in the desert climate or a tropical climate, then your hardware should be able to manage these temperature variations because this affects your image sense. Thirdly, you need to worry about the weather. Rain, snow, fog, etc. heavily affect the visibility of your camera. Finally, the fourth problem you will encounter is motion. Your camera should be able to capture fast moving objects, which is mainly one of the major needs in many outdoor use cases. But this is very difficult even in indoor environments, but based on the previous factors we spoke about, becomes doubly difficult in outdoor environment. Looking at these four factors, and if you want to delve deep into each one of these four factors and see how we can mitigate it, is a large conversation in itself. So in this podcast, I will just focus on some of the lighting problems you will face and how you can use tricks surrounding hardware and your algorithms to mitigate that. This lighting noise, also called ambient lighting, is actually pretty solvable in indoor environments. What we basically do is we build shrouds around particular computer vision equipment, or we use high power lighting equipment to overpower this ambient lighting. But these kind of solutions cannot be actually used in outdoor environments. And more than computer vision, this problem plagues machine vision cameras. And that's one of the major reasons why machine vision has still not come out of the indoor use cases world. But then in computer vision, this problem is actually pretty solvable. By using the right embedded camera or a combination of embedded cameras along with the rightly modeled algorithms, we can kick this problem off the road. So in this scenario, the most important thing we need to understand about managing a lighting problem for computer vision applications is that the algorithm we create should be able to manage both day and night lighting. Looking at it from the hardware side, night vision can be handled by providing some form of lighting, or we can also use IR lighting as we use in some common CCTV cameras. But here it's important to note, IR beams have only short bandwidth of 15 to 20 meters. So you need to be careful in placing your cameras. So the right placement of cameras is necessary if you are going to fulfill the objectives of your use case, especially when it comes to viewing during the nighttime. Here, it's not just the camera that you focus on to manage your nighttime view. You also have to have the right modeled algorithms. Your algorithms must be able to manage both day and night vision data. But here, the major problem you will face is managing the accuracy of your algorithm, especially during nighttime. This is because of the lack of correct data to model your algorithm. For model development, we need to collect equal amounts of data for both daytime lighting and nighttime lighting. In most scenarios, our models are actually trained for daytime lighting, but incidentally, we do not have much data for nighttime lighting. One of the ways I solve this problem is by taking a camera and placing this in the client's place in the required location for a month and collecting the data and then taking it back, annotating it and training my model and making it have better accuracy based on this nighttime data. If the customer does not agree to this method, then the easier method for solving this problem is by using augmentation for simulating nightlight images. In a world where privacy is becoming paramount, actually is not a good idea to take your camera and place it in your client's place and record the data. The whole point of an edge optimized computer vision application is lost when you stream the video back to the cloud, right? But then I digress from the topic. Augmentation of data for simulating night lighting images include reduced brightness, changing your contrast, or even conversion of the image into grayscale. But then there is also another way my team from VisAI Labs creates data sets for night lighting images. They use Ganbased network. So by using Ganbased networks or through augmentation, what we do is that we build a respectable data set with which we can train our ML models. Also, another critical part is getting your algorithms working in different weather conditions such as rain, fog, snow, sleet, etc. Right now, it is very difficult to manage these things as these weather conditions tend to occlude the objects. Whilst it is really good for us to have an algorithm which has been trained heavily with data sets from both daytime and nighttime across all these different weather conditions, you will have a heavy problem of false positives if you take this heavily occluded data, annotate it, and train your algorithm using it. So you need to be mindful of this fact when you actually take this kind of data and you train your system to work in outdoor environments. These are some of the things you need to look into while building a right fit algorithm for your outdoor use case. Now coming into hardware, you need to make sure that your embedded camera has good HDR capabilities with low exposure times so that you can take good quality images in both day and night lighting conditions. Also, as for the other hardware, you need to have the right rugged casing with water and dust resistance, which also takes care of the mild temperature variations your hardware will be subjected to. All in all, there is no one correct way to solve all the different ambient lighting problems you will face when building an outdoor-based use case for your computer vision application. But then, using a combination of ingenuity and creativity combined with a solid knowledge of digital image processing basics, you can get the job done. Thank you for tuning in into yet another episode of Unraveling Computer Vision and Edge AI for the Real World. This is Alphonse signing off and looking forward to meet you in future episodes. Ciao.